The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
The first thing we are going to talk about is basically acid derivatives in general. Now, they are a group of closely related compounds that are derivatives of carboxylic acids. Acid derivatives have an acyl group bound to a heteroatom. Now, this right here is the acyl group that I'm highlighting, okay? The acyl group right there will be the carbonyl bound to that alkyl chain, and the heteroatom that we're talking about would be the X, which can be represented by chloride, chlorine. In the case of an acid chloride, that would be an acid halide. It can also be represented by that carboxylate group right there. In the case of an anhydride, it can also be represented by that alkoxy group in an ester and by the amino group in an amide. So as you can see, we pretty much have the same functionality in that we have our acyl group, and in all these different compounds, it is bound to a different substituent. Now, all of these compounds are referred to as carboxylic acid derivatives, and remember, this list is not exhaustive. We're just pretty much tackling the ones that you are going to need for your exam. We have additional derivatives such as the nitriles that we're not going to be talking about today. Now, all of these derivatives right here can be prepared from their parent acids in a very simple reaction, and we talked about this when we studied organic acids, and the reaction was nucleophilic acyl substitution. Okay, so that is the reaction that can be used to prepare all of these derivatives from their parent acids. So as you might expect, because you can derive or prepare each of these derivatives from their parent acids, you could also expect that you can hydrolyze each of these acid derivatives, each of these compounds, back into their original carboxylic acid. So we're going to delve into the first classification, or the first member of this group, which are the acyl halides. They have a pretty simple general formula that looks something like this. Where the X can be any halogen. Okay, so for the most part, we'll be dealing with acyl chlorides, but that is a general formula for an acyl halide, where the X can be any halogen. Okay, so as far as naming them is concerned, pretty simple rules. What you're going to do is replace the IC in what would be the parent acid name with YL and add the corresponding halide name as a suffix. Okay, so the best way to understand what that means is by doing an example. So if I'm going to direct your attention to the first example we have on the screen. Now, if that compound right there was an acid, we'd have a hydroxyl group in place of that chloride atom right there. And this is the simplest acid you can have, referred to as methanoic acid. So what this rule is telling us to do is basically to drop the IC, replace it with YL, which gives us methanoyl, and then we are going to include the halide name as a suffix. Okay? So putting that information together would give us methanoyl, since we have a chlorine atom at that position right there, chloride, and that's basically the name of that acyl halide. So as you can see, it's pretty simple. I'm just going to include that name very clearly. The name of that compound would be methanoyl chloride.